Hi all. Now we are going to see the arithmetic and logical instructions for 8086. In my previous video, you can check the data transfer instructions for the 8086 instruction set. We are in this arithmetic and logical instructions. We'll move into it. First, as I mentioned, once you call it as arithmetic, we'll be performing the basic arithmetic operations, add and subtract. So we'll be adding two datas. So the content or data in the source register or the memory address will be summed up or added with the destination register. So here the content immediate data 0f will be added with the content in the AL register, and the result will be finally stored in the AL itself. And here, most importantly, unlike the data transfer, here in data transfer the flags were not affected, whereas here, since a arithmetic operation is performed, the flags get affected, and all the flags like auxiliary flag, carry flag, overflow, parity, sign, and zero flags are getting affected based on the addition operation. So you may get a carry or you might not get a carry based on which the flags may get either set or reset. Again, here in this second example, we'll have the content in BX and AX, and so the two contents are summed up or added, and the final result will be stored in the AX. So these are the different examples. I've also mentioned what type of addressing modes they are. For an example, here it is like this is an address, 5000 is an address, and the content in this address will be summed up with the content in the AX, and the final result will be available in the AX. And this immediate data 0100 will be added with the content in this 5000H, and that will be stored in the 5000H itself. In the previous case, it was just addition without carry, whereas here, when you put C in the instruction, it implies that we'll add the content from to register or memory place, whatever it is. So this content in the BX and the content in AX are summed up along with the carry. And so based on this, the flags are getting anyway affected, or obviously there will be a change in the flags. So whenever we have a ADC or instead of ADD, obviously that implies that we'll be adding the two contents along with the carry. These are the different examples shown here. Like addition, it is going to be the subtraction operation. So we'll perform a subtraction between the immediate data, the same example as we took 0f and the content in the AL. Now it was just the addition done there. Now here it is going to be the subtraction. So the contents of the destination will be subtracted with the source register, and the final result will be stored in the destination itself. In this case, we'll just do the subtraction between these two contents along with the borrow, like carry, what we did in case of add. Next comes the compare. So here, the point of doing a comparison is it actually compares the source operand, or it just compares the content between these two. And of course, the result is not stored in any place, but there will be a change, or there will be a reflection, or the flags get affected because of this comparison. So here the data 0100 is compared with the content in the BX, and accordingly the flags get changed. Same happens here. This is 0100 is compared with the content in the memory address 5000. Next is increment and decrement. So this instruction implies that whatever in the AL will be incremented by 1, and whatever is in the AX will be incremented by 1. It is all incremented by 1. The point or the difference between AL and AX is will have 8-bit and AX is a 16-bit register. Same happens, or same implies for the decrement. Whatever will be the content in the particular register mentioned here, that will be decremented by 1. Until now, we have seen about the arithmetic operations. We are now moving on to the logical operations. Once we say logical operation, it can be AND, OR XOR, any sort of logical operations. Hope you all know what is an AND operation. So here let us assume this is my content of BL and AL, So it is 100000110 and 11001010. Now if I want to perform an AND operation, we all know that AND works or an output of AND will be high only if both the bits are high. Say for an example, this is the LSB of BL, this is the LSB, so bit 0, first bit, second bit, you can call it anyway. So when I compare 0 with 0, it is 0, 1 with 1, it's becoming 1, 0 with 1, when you do the AND operation, it is going to be 0, 1 with 0 is 0, again these two bits are also 0, and other than the MSB, it's all going to be 0 because in the MSB alone, it is both being 1 when we do the perform the operation of AND. So the final result will be like this. Yeah, that's what we concluded, and that will be stored in the BL. Likewise, we perform the AND operation between the AX and CX here, and here the immediate data is represented. So the 08 data will be compared with the content in the CL. AND operation, I'm sorry. Same, here we perform the OR operation. So say same example is taken. In an OR operation, even if one bit is high, the output will be high. So here 0 and 0, it is 0, 1, and 1, it is 1. So it is 1, 0, it becomes 1, and 0 and 1 is also 1. These two bits are 0, 0, so it is 0. And for the last two bits, it's going to be 1 because even if one bit is high, the output will be high. And so our output will be 1100, 1110, and which will be stored in the BL. Same here, we do the OR operation between the contents of CX and AX, and the final result will be in the CX. And here the immediate data 08 will be OR with the CL content, and the final will be stored in the CL. Not as just inverting or complementing the content, or whenever we have 1, it becomes 0. Say for an example, I have a content in the AX, bitwise will be bitwise it will be inverted. So say if I have 1011, this 1 becomes 0, this 1 becomes 0, 0 becomes 1, and 1 becomes 0. So after executing this instruction, right now my AX will have 0100. Same for this instruction. Here the memory address 5000 will have a content which will be not, or which will be inverted. The contents of that 5000 will be inverted or complemented. XOR is XOR operation when even if one bit is high, the output is high. Even if both the bits are same, if both the bits are same, then obviously output will be 0. So say like if you have an instruction, if you have a value of 1011 and 1100, then you compare, you can easily understand if both are 0 or if both are 1, then obviously the output will be 0. Even if one is high and the other one is low, then the output will become 1, and the final result will be stored in the destination register. Here we have immediate data 0098, and the content in the AX will be XORed, and that result will be put into the AX. Same here, in this case we have content in the 5000 memory address, and that will be XORed with the content in the AX, and which is stored in the AX itself. For this instruction, it is the content between BX and AX are XORed, and the final result will be in the AX. Thank you.